Operational pitfalls. Although more experienced pilots are likely to make more automatic decisions, there are tendencies or operational pitfalls that come with the development of pilot experience. These are classic behavioral traps into which pilots have been known to fall. More experienced pilots, as a rule, try to complete a flight as planned, please passengers, and meet schedules. The desire to meet these goals can have an adverse effect on safety and contribute to an unrealistic assessment of piloting skills. All experienced pilots have fallen prey to or have been tempted by one or more of these tendencies in their flying careers. These dangerous tendencies or behavior patterns, which must be identified and eliminated, include the operational pitfalls shown in the figure. Stress management. Everyone is stressed to some degree almost all of the time. A certain amount of stress is good since it keeps a person alert and prevents complacency. Effects of stress are cumulative, and if the pilot does not cope with them in an appropriate way, they can eventually add up to an intolerable burden. Performance generally increases with the onset of stress, peaks, and then begins to fall off rapidly as stress levels exceed a person's ability to cope. The ability to make effective decisions during flight can be impaired by stress. There are two categories of stress: acute and chronic. Factors referred to as stressors can increase a pilot's risk of error in the flight deck. There are several techniques to help manage the accumulation of life stresses and prevent stress overload. For example, to help reduce stress levels, set aside time for relaxation each day or maintain a program of physical fitness. To prevent stress overload, learn to manage time more effectively to avoid pressures imposed by getting behind schedule and not meeting deadlines. Use of resources. To make informed decisions during flight operations, a pilot must also become aware of the resources found inside and outside the flight deck. Since useful tools and sources of information may not always be readily apparent, learning to recognize these resources is an essential part of ADM training. Resources must not only be identified, but a pilot must also develop the skills to evaluate whether there is time to use a particular resource and the impact its use will have upon the safety of flight. For example, the assistance of ATC may be very useful if a pilot becomes lost, but in an emergency situation, there may be no time available to contact ATC. Internal resources. One of the most underutilized resources may be the person in the right seat, even if the passenger has no flying experience. When appropriate, the PIC can ask passengers to assist with certain tasks, such as watching for traffic or reading checklist items. Some other ways a passenger can assist: provide information in an irregular situation, especially if familiar with flying. A strange smell or sound may alert a passenger to a potential problem. Confirm after the pilot that the landing gear is down. Learn to look at the altimeter for a given altitude in a descent. Listen to logic or lack of logic. Also, the process of a verbal briefing, which can happen whether or not passengers are aboard, can help the PIC in the decision-making process. When flying alone, another internal resource is verbal communication. It has been established that verbal communication reinforces an activity. Touching an object while communicating further enhances the probability an activity has been accomplished. For this reason, many solo pilots read the checklist out loud. When they reach critical items, they touch the switch or control. For example, to ascertain the landing gear is down, the pilot can read the checklist. But if he or she touches the gear handle during the process, a safe extension of the landing gear is confirmed. It is necessary for a pilot to have a thorough understanding of all the equipment and systems in the aircraft being flown. Lack of knowledge, such as knowing if the oil pressure gauge is direct reading or uses a sensor, is the difference between making a wise decision or a poor one that leads to a tragic error. Checklists are essential flight deck internal resources. They are used to verify the aircraft instruments and systems are checked, set, and operating properly, as well as ensuring the proper procedures are performed if there is a system malfunction or in-flight emergency. Students reluctant to use checklists can be reminded that pilots of all levels of experience refer to checklists, and that the more advanced the aircraft is, the more crucial checklists become. In addition, the Pilot's Operating Handbook, POH, is required to be carried on board the aircraft and is essential for accurate flight planning and resolving in-flight equipment malfunctions. However, the most valuable resource a pilot has is the ability to manage workload, whether alone or with others. External resources. Air traffic controllers and flight service specialists are the best external resources during flight. In order to promote the safe, orderly flow of air traffic around airports and along flight routes, the ATC provides pilots with traffic advisories, radar vectors, and assistance in emergency situations. Although it is the PIC's responsibility to make the flight as safe as possible, a pilot with a problem can request assistance from ATC. For example, if a pilot needs to level off, be given a vector, or decrease speed, ATC assists and becomes integrated as part of the crew. The services provided by ATC can not only decrease pilot workload, but also help pilots make informed in-flight decisions. The FSS are air traffic facilities that provide pilot briefing, en route communications, VFR search and rescue services, assist lost aircraft and aircraft in emergency situations, relay ATC clearances, originate notices to airmen, NOTAMs, broadcast aviation weather and National Airspace System, NAS information, receive and process IFR flight plans, and monitor navigational aids, nav aids. In addition, at selected locations, FSSs provide en route flight advisory service, Flight Watch, issue airport advisories, and advise Customs and Immigration of trans-border flights. Selected FSSs in Alaska also provide TWEB recordings and take weather observations. Another external resource available to pilots is the VHF Direction Finder, VHF-DF. This is one of the common systems that helps pilots without their being aware of its operation. FAA facilities that provide VHF-DF service are identified in the AFD. DF equipment has long been used to locate lost aircraft and to guide aircraft to areas of good weather or to airports. DF instrument approaches may be given to aircraft in a distress or urgency condition. Experience has shown that most emergencies requiring DF assistance involve pilots with little flight experience. With this in mind, DF approach procedures provide maximum flight stability in the approach by using small turns and wings-level descents. The DF specialist will give the pilot headings to fly and tell the pilot when to begin descent. If followed, the headings will lead the aircraft to a predetermined point, such as the DF station or an airport. To become familiar with the procedures and other benefits of DF, pilots are urged to request practice DF guidance and approaches in VFR weather conditions. Situational awareness. Situational awareness is the accurate perception and understanding of all the factors and conditions within the 5 fundamental risk elements: flight, pilot, aircraft, environment, and type of operation that comprise any given aviation situation that affect safety before, during, and after the flight. Monitoring radio communications for traffic, weather discussion, and ATC communication can enhance situational awareness by helping the pilot develop a mental picture of what is happening. Maintaining situational awareness requires an understanding of the relative significance of all flight-related factors and their future impact on the flight. When a pilot understands what is going on and has an overview of the total operation, he or she is not fixated on one perceived significant factor. Not only is it important for a pilot to know the aircraft's geographical location, it is also important he or she understand what is happening. For instance, while flying above Richmond, Virginia, toward Dulles Airport or Leesburg, the pilot should know why he or she is being vectored and be able to anticipate spatial location. A pilot who is simply making turns without understanding why has added an additional burden to his or her management in the event of an emergency. To maintain situational awareness, all of the skills involved in ADM are used. Obstacles to maintaining situational awareness. Fatigue, stress, and work overload can cause a pilot to fixate on a single perceived important item and reduce an overall situational awareness of the flight. A contributing factor in many accidents is the distraction that diverts the pilot's attention from monitoring the instruments or scanning outside the aircraft. Many flight deck distractions begin as a minor problem, such as a gauge that's not reading correctly, but result in accidents as the pilot diverts attention to the perceived problem and neglects to properly control the aircraft. Workload management. Effective workload management ensures essential operations are accomplished by planning, prioritizing, and sequencing tasks to avoid work overload. As experience is gained, a pilot learns to recognize future workload requirements and can prepare for high workload periods during times of low workload. Reviewing the appropriate chart and setting radio frequencies well in advance of when they are needed helps reduce workload as the flight nears the airport. In addition, a pilot should listen to ATIS, Automated Surface Observation System, or Automated Weather Observation System if available, and then monitor the tower frequency or Common Traffic Advisory frequency to get a good idea of what traffic conditions to expect. Checklists should be performed well in advance so there is time to focus on traffic and ATC instructions. These procedures are especially important prior to entering a high-density traffic area, such as Class B airspace. Recognizing a work overload situation is also an important component of managing workload. The first effect of high workload is that the pilot may be working harder but accomplishing less. As workload increases, attention cannot be devoted to several tasks at one time, and the pilot may begin to focus on one item. When a pilot becomes task-saturated, there is no awareness of input from various sources, so decisions may be made on incomplete information and the possibility of error increases. When a work overload situation exists, a pilot needs to stop, think, slow down, and prioritize. It is important to understand how to decrease workload. For example, in the case of the cabin door that opened in VFR flight, the impact on workload should be insignificant. If the cabin door opens under IFR or different conditions, its impact on workload will change. Therefore, placing a situation in the proper perspective, remaining calm, and thinking rationally are key elements in reducing stress and increasing the capacity to fly safely. This ability depends on experience, discipline, and training. Managing risks. The ability to manage risk begins with preparation. Here are some things a pilot can do to manage overall risk. Assess the flight's risk based on experience. Use some form of risk assessment. For example, if the weather is marginal and the pilot has low IMC training, it is probably a good idea to cancel the flight. Brief passengers using the safety list. S. Seatbelts fastened for taxi, takeoff, and landing. Shoulder harnesses fastened for takeoff and landing. Seat position adjusted and locked in place. A. Air vents, location, and operation. All environmental controls discussed. Action in case of any passenger discomfort. F. Fire extinguisher, location, and operation. E. Exit doors, how to secure, how to open. Emergency evacuation plan. Emergency survival kit, location, and contents. T, traffic, scanning, spotting, notifying pilot. Talking, sterile flight deck expectations. Y, your questions. Speak up. In addition to the safety list, discuss with passengers whether or not smoking is permitted, flight route altitudes, time en route, destination, weather during the flight, expected weather at the destination, controls and what they do, and the general capabilities and limitations of the aircraft. Use a sterile flight deck, one that is completely silent with no pilot communication with passengers or by passengers from the time of departure to the first intermediate altitude and clearance from the local airspace. Use a sterile flight deck during arrival from the first radar vector for approach or descent for the approach. Keep passengers informed during times when the workload is low. Consider using the passenger in the right seat for simple tasks such as holding the chart. This relieves the pilot of a task. Automation. In the GA community, an automated aircraft is generally comprised of an integrated advanced avionics system consisting of a primary flight display, PFD, a multifunction flight display, MFD, including an instrument-certified global positioning system, GPS, with traffic and terrain graphics, and a fully integrated autopilot. This type of aircraft is commonly known as an advanced avionics aircraft. In an advanced avionics aircraft, there are typically two display computer screens, PFD left display screen, and the MFD. Automation is the single most important advance in aviation technologies. Electronic flight displays, EFDs, have made vast improvements in how information is displayed and what information is available to the pilot. Pilots can access electronic databases that contain all of the information traditionally contained in multiple handbooks, reducing clutter in the flight deck. Multifunction displays, MFDs, are capable of displaying moving maps that mirror sectional charts. These detailed displays depict all airspace, including temporary flight restrictions, TFRs. MFDs are so descriptive that many pilots fall into the trap of relying solely on the moving maps for navigation. Pilots also draw upon the database to familiarize themselves with departure and destination airport information. More pilots now rely on electronic databases for flight planning and use automated flight planning tools rather than planning the flight by the traditional methods of laying out the charts, drawing the course, identifying navigation points, assuming a VFR flight, and using the POH to figure out the weight and balance and performance charts. Whichever method a pilot chooses to plan a flight, it is important to remember to check and confirm calculations. Although automation has made flying safer, automated systems can make some errors more evident and sometimes hide other errors or make them less evident. There are concerns about the effect of automation on pilots. In a study published in 1995, the British Airline Pilots Association officially voiced its concern that airline pilots increasingly lack basic flying skills as a result of reliance on automation. This reliance on automation translates into a lack of basic flying skills that may affect the pilot's ability to cope with an in-flight emergency, such as a sudden mechanical failure. The worry that pilots are becoming too reliant on automated systems and are not being encouraged or trained to fly manually has grown with the increase in the number of MFD flight decks. As automated flight decks began entering everyday line operations, instructors and check airmen grew concerned about some of the unanticipated side effects. Despite the promise of reducing human mistakes, the flight managers reported the automation actually created much larger errors at times. In the terminal environment, the workload in an automated flight deck actually seemed higher than in the older analog flight decks. At other times, the automation seemed to lull the flight crews into complacency. Over time, concerns surfaced that the manual flying skills of the automated flight crews deteriorated due to over-reliance on computers. The flight crew managers said they worried that pilots would have less stick and rudder proficiency when those skills were needed to manually resume direct control of the aircraft. A major study was conducted to evaluate the performance of two groups of pilots. The control group was composed of pilots who flew an older version of a common twin-jet airliner, equipped with analog instrumentation, and the experimental group was composed of pilots who flew the same aircraft, but newer models equipped with an electronic flight instrument system, EFIS, and a flight management system, FMS. The pilots were evaluated in maintaining aircraft parameters such as heading, altitude, airspeed, glide slope, and localizer deviations, as well as pilot control inputs. These were recorded during a variety of normal, abnormal, and emergency maneuvers during 4 hours of simulator sessions. We hope you learned a lot. Please help us spread the word about Pilot Training System, and we look forward to further servicing your flight training needs.